All right, so this is how we're going to work this. Again, chapters 12, 13, 14, 15, 16, and 17, that makes up most of the rest of what's in the book. I'm going to go over those with you. There'll be no written test. There'll be no homework. I'm doing those for completeness. And you'll see that stuff again next semester. So my plan is I'm going to go over 11 and 12 today. Tomorrow I'll go over 13 and 14. And we will go over that program that or the thing that we looked at. Remember that form we looked at and how to, I've got it done in just using JavaScript. Then we'll go back and do it one more time on Wednesday using just jQuery. Then Thursday you'll have a test, which I'll basically ask you to replicate that and put a couple more things in. Friday we'll go over chapter 17. All next week will be lab for you to finish everything up. You're in real good shape. She's having problems. And I was also told by, well, I won't do it now, but I was told by Brandon that, and when I say she has problems, I just mean she's behind on her work. That's all. I'm hoping she gets it in. I want her to be in the class. So let's take a look in here. We are on advanced JavaScript skills, okay? And chapter 13, and I guess that's the one we're on. That's on numbers and strings. 14 is on control structures and exceptions. You know, they talk about control structures. You've been using ifs, switches, loops. I'm not going to go over that stuff. I don't know why they would wait till that part of the book to do that. That's what they did. So I don't unless you feel the need to go over that, I'm not going to. So first they talk about numbers and dates, and I think we mentioned this already, but I do want to make sure you know this. Technically, JavaScript only supports for numbers. All numbers are looked at as being the same. They're all numbers. Now, if you want just a whole number, it's a parse int. If you want a number with a decimal, it's a parse float. You know that, but they're all just numbers to JavaScript. All right, so we'll talk a little bit about that. Then they show you this game. I don't know why, but for whatever reason, Muroc is kind of infatuated with games. I don't know if you've ever heard of a game called Pig. You sit, and the idea is you want to keep shaking the dice till you get to 100. Okay? But anytime you get a 1, you got to start over again. So they show you the HTML and the JavaScript to do that game. We can look at it, but I'm not going to spend hardly any time on it. Strings we've looked at a little bit, but we'll talk about them some more. And finally, dates and times. This countdown thing is how many days is it till New Year's. Okay? I imagine this will take 15 minutes or so, and then we'll do the next chapter. And I guess I said it wrong, because today's 13, 14, tomorrow's 15, 16. Wednesday, we'll do 17. Thursday, then, can be your test. Friday, then, it'll be lab all day, so you'll get 5 straight lab days. All right. Now, with you, if it turns out that you say, well, in one day I did my entire portfolio. I don't know what, then I can show you what we'll be working on next semester if you want to see it. Okay, well, then we can take a look at that later on in the week. All right. So, a couple things with JavaScript and numbers. These are properties. So if you printed out number.maxValue, that would show you the biggest number that your computer can hold for a number. Does that make sense? Min value would be the smallest. Then there's infinities. You know what NaN is already, so I'm not going to go over that with you. When you do toString, we've talked about this, but not really in any depth. ToString will take anything and convert it to a string. So if I say this, var age equals 63, and then I say age equals age dot toString. Right now, age has the value of 63. Now age has the value of a 6 and a 3. It has no arithmetic value. Does that make sense? Because most programming languages let you do this and convert things to strings. You're going to see it again next semester as well. Okay. All right. More stuff with a math object, math.pi. Do I have to say what that is? You know, it shows you pi 3.14159. You can see how many decimal places it shows it to. There's a bunch of things that are in here. ABS. If I say to you, Keegan, how old are you? And you say, I'm 22, let's just say. All right. Then if I'm 63 and you're 22, there's 41 years between us, correct? Doesn't matter if I say 63 minus 22 or 22 minus 63. The problem is if I say 22 minus 63, I get a negative number. So absolute value says you don't care about the sign. All right. Round does rounding. Ceil and floor are kind of neat. Ceiling, if you've got 0.5 or above, all right, in fact, ceiling will always round up. Even 1.2 will round up to 2. Floor will always round down. Even 1.9, okay, it'll round down. Okay. Pow is how you can do things to power. So if I say var x equals 23, and I put in here math.pow 23, comma 2, that's 23 squared. That make sense? I could also just say 23 times 23. But the problem is if you get something like up to the 7th power, if you really want to say 23 times 23 times 23 times 23 times 23 times 23 times 23, or put a 23 here and a 7. Okay? Square root. This is kind of neat. Max and min. I can provide a whole list of numbers, and it'll show me the biggest one or the smallest one. If there's two that have the same value and it's the biggest or smallest, it's just showing me the biggest or smallest. It doesn't show me where it is. It just shows me which is the biggest or which is the smallest. That makes sense? Okay. Random numbers. We did look at this a little bit last week when I was gone Friday, and I can show it to you if you want to see it. I don't even know if I still have it up here or not, but let's see. Yeah, I do. Or do I? No, I don't. All right. If I run this, that's the wrong one. There it is. Is that pretty obvious what that game's going to do? So if I come in here and I say 50, and it says it was too high, see how it disappears to? 25, still too high. 13, too high. 6, too low. So I know it's between 7 and 12. Does that make sense? The point is when I click here or when I start the game, I get a brand new number. And to do that, just wanted to show this to you. There it is. Where is it? There. When you run a random number, you literally get a number between 0 and 1. That's how random numbers work. It's a number that's 0 or more, but less than 1. So what I'm saying is multiply that number by 100. So if it was like 0.23, it would become 23. And then just grab the floor or the smallest value. So throw away any decimal place. This will give you a number, a random number between 1 and 100. Does that make sense? You're going to do some work next semester with random numbers. Not a lot, but once in a while. Oops. This is that pig application. There's the rules. You want to go over it? No. I mean, the JavaScript is kind of cool. They work with this. It's a random dice throw. Okay? And the bad thing is, since you go up to 100, you could play this. I don't know if you ever did it as a kid. Did you ever play the card game War? Did you ever have some with a friend or a sibling where it like takes hours? That's how this game is. Because if I'm at 99 and I'm just about there, first of all, if I get a 1, I'd get 100, but 1 would start me over again. So I wouldn't have it go to 100 like they do. I would probably knock it down to maybe 20 or 30 or whatever. I mean, there's nothing wrong with the game, so. All right. Here's some things you can do with strings. Strings, this is the length. Does that make sense? If I said hello, the length is 5. H-E-L-L-O. All right. Charat, we've used that. Remember that when we were, does it equal Y type of thing? We even really used concat. We use the plus sign. It does the same thing. A bunch of these things, index up, substring, we'll find, if somebody said to you, hey, Keegan, I want you to go and check the Constitution of the United States of America. And here it is. I want you to find how many times it says in there, people. You could search through there, so you could search the entire Constitution for just one thing. So that's a substring, so it's a string within a string. Okay? The 2 upper and 2 lower we've used. Nothing really new there. They've got a bunch of examples of working with strings. I'm not spending a lot of time on this because we're going to do it in spring anyway. All right, with C#. When you create a date object like this. So if I were to create a date object right there just like that, then now would hold 12/9/2019, and it would also hold 8/10. That makes sense? So you get both the date and the time. And that's what they're saying in here. The way that it does time is the way that virtually every programming language does time. And what I mean by that is it uses what's called the Unix epoch time. And that's how many milliseconds have transpired since January 1st, 1970. It actually figures out time that way. Why they do it like that, I have no clue. But that's how they do it. All right. When you work with dates, you can take that entire date and turn it into a string. You can grab just the date part, just the time part, and then from the date you can grab just the year or just the month, just the date or the day. From the time you can grab just the hours, just the minutes, just the seconds. It gives you the time up till the millisecond. That's how accurate it is. So anytime you see the word get in here, that is allowing you to retrieve it. Anytime you see the word set in here, it's allowing you to set it. Make sense? All right, so they give you some examples of working with them. And then there's this countdown application, which again, see that? You can put anything you want in there for an event. Typically, it would be like New Year's Day, Halloween, whatever, you know. And not a lot to it, really. Here's the JavaScript. Not really a lot in there either. But there shouldn't be anything in here that now you couldn't look at and figure out how to do. All right? That's it for that chapter. So let me stop here. Thought it'd be about 15 minutes or so. So